All right, guys, coming back from the little bit of a break, and you've hopefully completed this problem for me. So the nice thing about this one is it was already factored, so we've practiced enough factoring at this point. So kind of we wanted to come in, jump in right where we had it already in factored form. So what we're going to do first, and what I did is I found those critical points. So let's do pink, just so that. So critical points coming in right there. So set each factor equal to 0. And I did highlight there for you that the x minus 2 factor actually occurred twice. And so that was a double zero. And that's kind of going to be one of the main things, kind of the main points of why we looked at this example is that we have a double zero. We want to know what happens when you have that. And as you can see here below that I went through and I started running my tests, and we got a negative for the first, a positive for the second, a negative, and then a negative. So a lot of times students feel like the sign should always alternate. And that's not true. And what we see here, and kind of the main point of what this example was doing for you, is that if you don't have a sign change, the reason you don't have a sign change is because you had a double zero. You had a zero whose factor actually occurred more than once. And we actually are going to kind of highlight that when we talk about a double zero, what I'm really talking about is even multiplicity. That if the factor has an even power, even multiplicity, even power on the factored form, on the factor in factored form. And so when we're looking at that, then because we see that even factor on it, what that tells us is that it's not going to change sign. So the key here is, and kind of why we looked at this, is when do we have no sign change? We have no sign change when the factor has an even power. It's just going to be like in the graph, it actually just bounces. And if I slide down and take a look at the graph that was below, you can see down there, right here, I'll highlight where that 2 is, that did not change sign because it hit the x-axis and then just bounced. And since it was below, coming into it, it just bounced and stayed below and stayed negative when we were looking at it. So that kind of idea, is something that we want to pay attention to. And the other thing that I'm going to highlight is that the sign always changes when you have odd multiplicity. That odd multiplicity simply means that the power on the factor is odd. So odd power on the factor in factored form. And so that kind of idea is something that's pretty important, and that also helps you as you're kind of filling in your sign chart, because if you know that it has to change, if it's odd multiplicity, the sign has to change, versus it shouldn't change if it is even multiplicity. All right, and then you get your answer. Now, of course, referring back to coming down here to the bottom, we have our graph down here, and we want to know how does that graph confirm what we found algebraically. So when we're looking at this, the zeros, okay, are highlighted. Here's 0, -2, 0, and 2. Hold on one second. I think my dog needs to go out. Okay, coming back in to what we were looking at, I just highlighted that the zeros were at -2, 0, and 2. And then I also went through, or I haven't yet, but I will, is when you're looking at each of these intervals, and I'm just going to highlight them in green for above and red for below. So right now, the above, oops, that did not work. So the above sections, well, they'll be opposite. We'll do pink for above, would be here, and that's it. And then I'll do green sections for where you are below, here, here, and here. Now, when we look at this, and I didn't mention this earlier, but hopefully you saw this when we were looking at it, when we did our solution, and let me slide back up here, you do notice that kind of breaking it up here, that the intervals where I was below, which is what I was looking for because I was solving less than or equal to 0, that those intervals were negative infinity to negative 2, 0 to 2, and 2 to infinity. And so with those intervals, you would think that those would be our answer. And you're like, I'll just add brackets because of the equals. But what we want you to realize is that these two intervals, once you allow the equals to go in there, if there ends up being a bracket on the 2 here and on the 2 there, if you're including 2, don't make it 2 intervals. You combine them together, and that's why up here it ended up being 0 to infinity, because it's bracket 0 to 2, including 2, and going from 2 to infinity, so you just combine that together into one interval. Now, the last thing on this example, before we move on to a calculator problem, is what would we do if we were now asking the question, instead of less than or equal to, we want greater than or equal to. And the problem with that, and this is, messes students up a lot when we're looking at it, is the less than or equal to is fine. Y'all start with your parentheses and you're like, hey, it's -2 up to 0 and bracket. And then we have a problem because you're looking at it in terms of and there's a single value out on the side. It also happens at x equal to 2. We have to remember, don't forget to grab this single value that's not an interval that's there. I also don't, this is what I consider bad notation. Don't try to do interval notation and do something like this and say an interval of 2 to 2 or this. I don't like either of those because they really are not really good notation. So in terms of this, and you'll also notice that in these problems, I haven't been using union in between them. Technically, that is fine for a lot of these. Like if I was going to put this in actual set notation, instead of, say, listing the places where it has, which is all I've been doing up to this point, I would say -2 to 0 union, and then I would use curly braces to indicate it's the set that this interval is union this set. So we'll say set A union, this would be set B, and it happens to be a set that just has one object in it, and that's why you use the curly braces. But we don't really worry about that too much right now. I mean, the idea here is to be able to identify the values at where this happens. All right, I'm going to pause for a second, and then you guys go and get your calculators, because our next problem is going to use the calculator. Okay, now that you guys have your calculators and you're ready to kind of work with me on this problem. So the first thing that I want you to notice, sorry, I'm adjusting my computer here, is that there's one thing that's different about this. In all of the ones that came before, you'll notice that at that location, we were comparing it to 0. And so kind of the key to a lot of our sign charts that we're going to do is to make sure that you have 0 on one side. So what you're going to do is you're going to rearrange, okay, we're going to put this as need or must have 0 on one side, so that we can do our comparison. Our sign chart SIGN requires that you're comparing it to 0. So we must have 0 on one side. So it becomes x cubed minus 9x minus 3 greater than or equal to 0. So this is the inequality that we are going to be solving for this. Now, unfortunately, not every polynomial is factorable. It's not going to have the techniques that we used in the last section that you're going to be able to do. So when we're taking a look at this and we can't factor it, at some point we may need to use our calculator. So what we're going to do now, we're going to take this polynomial that we have, our x cubed minus 9x minus 3 greater than or equal to 0. And what we're going to do is we're going to use the calculator to help us determine what we're going to have. So what we're going to do is we're basically going to focus on this part right here. We're going to put that in y1, and we're going to graph that. So take a pause the video, and go ahead and put that into your calculator and graph it, and then come back and we'll talk about it. giving a little bit of wait time so that you guys can get that in. All right, so now what you're going to see there, now depending on, I'm going to come over here on my side that I have here so that you can see this. So I put it in my y equals x cubed minus 9x minus 3. I did a zoom standard as my starting value of what I was doing. Pretty straightforward. Most of us are going to do that as our start. And it gave me a picture that kind of looked like that. I wasn't happy with that window, even though I could see the 3 x-intercepts. And again, how many x-intercepts could you have? Up to a maximum of 3 because the degree was 3. So what I decided to do, and that's just my preference, if you need to change the window, you should change the window until you see all of the features that you're looking for in the graph. And I know that I have all the features because I know that the maximum number of x-intercepts would be 3 based on the degree. So I just changed, all I changed was that that this y value, oops, sorry, I just changed y max. That's the only thing that I changed in the problem was the y max. And when I did that, it gave me a picture that looked something like that. And now once you get that, then basically what you're going to do is you're going to then do second calc 0, right? Go into the second calc menu, which is right above the graph or the table menu, kind of in there on your calculator. Yeah, above the trace. So right above the trace button, you'll go into that, and that will give you the second calc and do left bound, right bound, like y'all are experts at that. And when I did that, I came up with these 3 values. So I just showed you what they were. One thing to kind of notice on this, and remember your calculator is doing a guess and check for finding these, that in that guess and check, notice that over here in this one, it didn't get 0 for the y value, but remember that's just scientific notation, and it's just because of it's estimating the 0, so it's okay if that says something weird like that 1 times 10 to the negative 12, because that's essentially 0. But the important numbers are going to be the values that are here, the value you found here, and the value that you found here. How do I get from one to the other? When you are looking at it, basically, all you're basically looking at is move your cursor when you do your guess close to the one that you want to find. All right, so I just wanted to show that to you over here. So now let's come back. Now, once we have those values, then what we're going to do is we want to answer the question. And so if you have the graph, I mean, it's really just doing the work and deciding now what should you do. Your graph is your quote unquote sign chart that you have going across. I'm going to pause this for a second. I'm going to fill in the graph above so that I can refer to it while I'm answering. All right, through the magic of pause. So here's the graph that we came up with. There's the 3 values that you've done second calc 0 for. And so basically all we're going to do now is find our solution. And so what we're looking at, we want greater than or equal to. So greater than or equal to 0 means we want the above, and we want to use brackets. So our above starts at the approximately, I like to put that in, negative 2.817 to approximately negative 0.338. And my other interval would be bracket approximately 3.154 to infinity. And then that would represent the solution for that inequality using the calculator. All right, so that's going to wrap up this set of notes. And so what you guys are going to do is come down here. You've got a nice worksheet to do the practice, and that will wrap up today's 2 lessons on reviewing factoring polynomials, reviewing x-intercepts and y-intercepts of polynomials and how we can find those, and being able to solve equations and inequalities by factoring and by using the graph. All right, we'll come back in for the next lesson to continue our polynomial review, but hopefully this is a good start. I'll see you guys later.